Yeah. Like that. And then zoom even more. Hold on. Zoom. Okay. So f of 3a. So the first thing I'm going to do is just write down f of x. Is it the glare? We can close the window. Should we close the blinds? Marvelous. Just on the right. I think pull the string to the left. Yeah. Let it be dark. Is that better? I don't want you to sleep in here. That is for after school. You guys, for real, only Keld knows this because he's the only person in my cats group in this room. But I have passed out during lunch. Like full on screaming in the room. Kids are playing basketball or I don't know. And I like passed out. My ability to sleep is unmatched. So I'm from Oregon originally, and I can sleep anywhere. So Portland, Oregon is the most bikeable city in the country as far as like transportation goes. Like people bike a lot, and it's a safe place to bike. Like you're not going to get hit by a car because most of the cars are pretty. I mean, you might get hit by a car, but I would not bike out here because I'm terrified of cars hitting people because they're not aware that bikes are on the road. Just because there's a picture of a bike on the road does not mean it's safe for bikes to be out there. Like cars are not used to bikes, it's not necessarily. Anyway, so in Portland, bikes are everywhere, so it's more safe. So when I was in Portland, if I got sleepy while I was biking, I would literally just be like, there's a bench right there. And I would like pull over the side of the road. I would lay down on the bench. I would put my helmet on my arm because who wants, I don't want to like wake up and my helmet's gone. So I would lock up my bike. I'd put my helmet on my arm and I would just lay down on the bench to take a nap. And one time I did that in a grassy area and I woke up surrounded by homeless people because I was like in their area. And I woke up and I was like, oh, sorry guys, it is getting a bit dark in here. See you tomorrow. Bye. Yeah, toodles. All right, so I'm going to go ahead and leave some space to plug 3a in because that is what I'm plugging in for x. So 3a. So this part right here is just notation. That's not actually mathing. I'm not mathing there, I'm just doing notation. Over here is where the mathing is happening. Yes? I would say, so the part we were doing before, this part right here, it's pretty typical for people to write the notation as part of the answer because the answer you're getting is literally a point. It's an x and a y coordinate, so a lot of people actually put the notation there. But once you get to stuff like this, honestly, most people don't put the notation anymore. They would probably not write the 2 times m of -1. They would probably just put 0. Here, they would probably not put all that. They would probably just put -16. So honestly, I'm about to ditch the notation. Yeah. Okay. So, yes. No. Good question. All right. So, I've got my notation here. I'm going to ignore this notation now. I'm just going to do the math part. What is 3 times 3a? 9a minus 7. Is there any way to combine those? No. Therefore, I am finished. Okay. Well, that one was all right. Okay, let me get my functions back. Yes. All right, number 6. We're going to find g of a plus 5. G of a plus 5. So I'm going to start out just by writing g of x, which was x squared minus x. Most people don't use capitals. Yeah. Lowercase is common. Yes, move. He decided he did not like me. He said she smells bad, and I said that's hurtful. I only teach this one. All 3 periods I teach during the day are different maths. I teach math 2, math 3, calculus. I have no repeats. Huh? Third period. Third period, I hang out by myself. I do not sleep. I do not sleep. I work on math. No, the sleeping happens after school. All right, so I wrote down g of x. I went ahead and I put all my x's in color so I know exactly what needs to be replaced. What am I replacing the x's with? A plus 5. Okay, so I'm going to rewrite this problem with some extra space because I'm plugging in something bigger this time. So squared. Okay, so I got some more space this time. So since I have 3 x's, I've got 3 sets of parentheses with some more space to plug in that a plus 5. And then I'm going to go ahead and do a plus 5, a plus 5, a plus 5. The g of a plus 5 in the beginning, I'm not going to worry about. That is just notation. So I'm going to kind of ignore this when I do my simplifying. Now, we do have a baby animal we can watch out for today. It is a kitten. We are going to watch out for kittens today. We cannot distribute this exponent. That's going to kill a kitten. That kills little kittens. Let's not kill them. Whenever we have a squared, it means there are 2 sets of parentheses, a plus 5 and a plus 5. And when we multiply them, we have to FOIL. Do not distribute that exponent. You need to FOIL. Okay? So I am going to FOIL that out. Before I do that, though, I can distribute this negative. That works. So negative a minus 5. So let's not kill kittens today. I am going to be walking around looking for it. And if you kill a kitten, I will let you know. And you can add a tally to the wall of shame. Yeah, you might have killed things and I just haven't noticed it. I also did notice I marked some of the dead baby animals from the first quiz test maybe. No, not the test because I haven't done that yet, but the first quiz, and then I forgot to mark them on the wall. So some of you guys got away with it. Yeah.
Have you marked your unicorn yet? For the lesson you did?
All right, so let's FOIL this. If I FOIL a plus 5, I've got a times a is a squared. A times 5, another a times 5, so that's 10a, and then 5 times 5, 25. If we factored, we'd go backwards. We just unfactored. FOILing is unfactoring. Yeah. All right, so we're going to go ahead and combine like terms, and what do we get? Okay. We are done. This is factorable, but we don't need to factor it because the instructions did not say to factor it. Yes? You could pull down the notation if you wanted to, but you don't have to. It is not common practice to do that. Good question. All right, we are going to move on to operations. Remember how my video said evaluating and operations, and then the video got too long, so I stopped? Remember that? That was funny. Okay, now we're going to do operations. Operations! All right, I'm going to use the same functions as before. So the same f, g, h, and m. But we're going to just do operations instead of straight up evaluating this time. So with operations, we have notation that makes common sense, and then we have lazy notation, okay? So the notation that makes common sense for addition is f of x plus g of x. What do you think you're doing with that? What do you think you're doing? You're adding them together. Well, Ms. Rice, that makes a lot of sense. So f of x plus g of x. Now, the lazy notation is f plus g of x. I'm so lazy, I didn't want to write x twice. So I shorthanded it, so I only had to write it once. Okay? This does not mean add something and then multiply by x. That is the common misunderstanding. This does not mean that. This means I am too lazy to write x twice. It means I'm lazy. So these are the same. It's the exact same thing. Take f, take g, add them together. Same thing. Okay? Two different notations, same thing. Yes? Both. They are both common. By the time you get to upper level math, you won't see either of them. You will literally see f plus g because people get even lazier. But in this class, you'll see that some of the x is involved in some parentheses, okay? But by the time you get into calculus in college, they drop all those parentheses. They say f plus g. We don't even put the x's in there. We know that you know what we're talking about. We say f plus g. Yeah. Because you don't always know what the numbers are. That meme is so old, Kel. We've all heard that before. Where is my eraser? At my desk. Okay, pretend that's gone, okay? Pretend that's gone. All right, so let's go ahead and take our f of x and our g of x. Let's add those together. So f of x is 3x minus 7. G of x is x squared minus x. I'm writing them in parentheses because f of x is the first one, g of x is the second one. Now, do those parentheses really need to be there? Not really. They're not really accomplishing anything. Ooh, sorry, I'm trying to zoom. Trying to zoom. I'm not zooming very well. Okay, that's about as zoomed as it will be. So I can go ahead and write them without the parentheses. The reason we're doing parentheses for this one is because with subtraction, the parentheses matter. With multiplication, the parentheses matter. So we're just going to be consistent. We're going to do parentheses every time. So you don't have to say, oh, sometimes I put them and sometimes I don't. Okay, so we're just going to do it every time because sometimes it makes a difference. So the parentheses here, there's nothing in front of the parentheses to distribute. There's nothing in front of the parentheses to distribute. So I can go ahead and just write them down. 3x minus 7 plus x squared minus x. Do we have any like terms we can combine? Yes. What do we have? Yeah, the 3x and the negative x. What is typically written first? The x squared. Okay, so I'm going to go ahead and write the x squared first. Then I'm going to do my combining of like terms. So the 3x and the negative x, what does that give me? 2x. And then I've got the negative 7. Okay, so there was my first operation. All right, here is my second operation, subtraction. Okay, so the obvious way to write subtraction is to do g of x. This time we're going to use h of x, g of x minus h of x. But they could also write it as g minus h of x if they want to shorthand it a little bit. So that's when they get further along and they start to shorthand things. Okay. So g was x squared minus x. Minus h was negative x to the third. So we're still putting each term in parentheses. It would matter more if h had two terms. H has one term right now, but if h had two terms, it would matter a little bit more. Okay. So the first set of parentheses, is there anything to distribute inside the parentheses? Nope, we can just copy those down. We got x squared minus x. The second set of parentheses, what do we need to do? Yeah, change it to adding. Minus minus makes a plus, plus x to the third. Now, you can say you're done here, But some of us might be a little bit like, ugh, about the order of that. So technically we don't have anything that's like term that needs to be combined, but our order is a little bit off. So what should we do to put it in the right order? All right, so there's our subtraction example. Next, multiplication. Miss Rice, where did you come up with these examples? They're so fun. I know, you guys, I know, they're so fun. All right, so for this one, we're going to do f of x times g of x. They might put the dot there. They might not put a dot. They might just write the letters right next to each other with no space. So they might do that. Or they could do this thing where they are lazy and they only write the x one time. Very fancy of them. So again, we're going to put the f of x and the g of x in parentheses, and the parentheses make a big difference this time. 3x minus 7, x squared minus x. And when the multiplication problem is written like this, what is our process of multiplying? FOIL. All right, so we got 3x multiplied by x squared. 3x cubed. And then we got 3x multiplied by negative x. Negative 3x squared. Okay, good. Good catch. And then we got negative 7 multiplied by x squared. Negative 7x squared. And then we got negative 7 multiplied by negative x. Positive 7x. Do we have any like terms to combine? Yes. Okay, so the middle term is negative 10x squared, and then we got 7x on the end. We are done. Okay. And then last, we got division. Yes. It depends on what functions you're using. Okay. Yeah. So we're gonna do I'm gonna write divided this way. Ooh, not ooh. I typoed. Help. Maybe I have an eraser in my bag? I have an eraser in my bag! Okay. Guys, look, I can clean this up. I thought this was a pen the whole time? Because it's a mechanical pencil. Okay, we got m of x divided by h of x. Or it could be m divided by h of x. So that's one way they could write division. Or they could write it with the actual little division symbol that you guys remember from elementary school. So you can see it either way. All right, m of x was the absolute value one. So that's negative absolute value of x plus 1. H of x was what? Negative x to the third. We're going to do, now typically when you do the division problems, you're not going to do any simplifying, typically. The reason you're not going to have to mess with division problems is because we literally have an entire unit dedicated to division. We call them rational functions. Rational means fraction. We have an entire unit dedicated to rational functions, which is why we won't really do anything, okay? Now, the only thing you are going to simplify today is if you got one whole chunk on the top like this, one whole chunk on the bottom, and you got a negative over a negative, and you can cancel out the negatives. This is the only thing that's okay, all right? Don't you dare try to simplify any numbers. You try to do that, you're going to kill a puppy. That's the thing that's going to get killed today. Don't you dare try to reduce those x's. That kills a puppy, okay? The only thing that's okay is that we had a negative on the top and a negative on the bottom, and we could get rid of those negatives, okay? Typically in the division problems, you will write the top and the bottom and you will do nothing. Everybody loves division because it is the easiest thing. The reason it's easy is because we have to spend a whole unit on it later in the semester, okay? That's why it's easy today, is because it's hard later on. Does that make sense? Okay, so that's it. We're done with division. All right, Ms. Rice, what about the more difficult examples? I'm glad you asked. Example 7. All right, now did you guys notice with all of those that they said, like, just plug in x, don't plug in something else for x? We didn't even get our colors out for that. So let's combine the two. Let's do operations, but plug in some numbers. Are you guys ready? Are you ready? Are you ready? Are you ready? We can do it. Okay, we can do it. Okay. All right, so we're going to do f plus g. And we're going to plug in -1. That's what that notation means. It means you're going to do f plus g. And you're going to plug in -1. So the cool thing about this is that you have the power to choose, okay? You're going to choose, do I want to do f plus g first? Or do I want to plug in 1 first? Okay? So you can plug in 1 to f, -1. You can plug in -1 to f, and plug in -1 to g, and then add them together. Okay, that's one option. Or you can take f and g and add them together and get an answer, and then plug in -1. You can do whichever way you choose. Okay? Which way sounds better to you guys? Do you want to plug in -1 first? Or do you want to do f and g added together first and then plug in -1? We have to decide as a class because we're going to do this consistent. So whatever we decide, this is how we're going to do it as a class. You want to try it and then decide as a class what we're going to do from then on? That's the way. Okay, so what should we do for the first one? Plug the -1 in first and then add them? Honestly, I think probably plugging the number in first and then adding them is probably easier. I'm going to be honest. Okay, so let's write this in the better notation. The better notation is f of -1 plus g of -1, because this notation is not shortcut. It's a little bit more common sense. Does that make sense? It makes a little bit more sense to your brain. So this notation and this notation are the same. One of them is lazy, one of them is not. Okay? So what we're going to do is we're going to find f of -1, we're going to find g of -1, then we're going to take those answers, we're going to add them together. Right, Rihanna? Exactly. Okay. So f of x so f of x is that, g of x is x squared minus x, and for both of those we're going to plug in a -1. So I'm doing my colors because I'm plugging in a number. Okay, so I got f of -1 is 3 times -1 minus 7. G of -1 is -1 squared minus -1. Do we see how I'm doing that? How are your brains feeling about it? Do you have any questions? Brains are okay? Okay. What is 3 times -1? -3. 3 negative? The negative part of 3. -3 minus 7 is -10. Okay. So there's our first number. I'm going to circle it. So I'm not quite finished yet. All right. And then over here, we got -1 squared, which is 1. Okay. Now we got a minus minus. What happens with a minus minus? plus. They cancel each other out, make a plus. Minus minus makes a plus. So we got 1 plus 1 is 2. Okay, so we got our two numbers. We're taking those two numbers, we're going to go back, we're going to add them together. So f of negative 1 plus g of negative 1 is actually negative 10 plus 2. What is negative 10 plus 2? Negative 8. That's our answer. Well, that was really fun. Okay, if we had done it the other way would have been to write f of x plus g of x, do all this work down here, and then take this answer right here and plug in negative 1. That's the other method. You like the method we used? Say it again? Nope, that was it. Okay. I mean, I could, but you wouldn't get any credit for it. Do you want me to do that? Because we're not halfway through the unit. Do you guys just want a daily quiz? Do you want me to give you a quiz or no? Okay. So are we rejecting what court has said? Okay. Okay, I'm going to give you guys another one. Are you guys ready? 2m minus h of 1. Okay. 2m minus h of 1. This is going to take a little bit more brain power because it's got that 2. It's got the 2 with the m, so that makes it just a little bit different. Okay. Let's take this out of this notation because this notation is just the worst thing. It is the worst. So let's kind of ignore the 2 for a second. What would this notation typically mean? Okay. But it's not m of x, it's m of 1 minus h of 1. Okay. And then what does it mean that it's got the 2 in front of the m? There's 2 m of 1s. Very good. Okay. All right, let's go ahead and do the math. So I'm going to write m of x equals m of x was negative absolute value of x plus 1. Okay. H of 1, or h of x, sorry, is negative x to the third. Okay. So I'm going to think about plugging 1 into each of these. Okay. So we've got m of 1 equals negative 1 plus 1. H of 1 equals negative 1 cubed. So I'm making sure I got space to plug those 1's in. So m of 1, h of 1. Okay. Are we comfortable so far? Yes. Oh, that was, I've been using the same 4 functions the whole time from the video notes. So as I've said, f and g and h and m, I've just been using these 4 functions all the way through the notes. Just to be consistent. So that's pretty typical in this type of thing, is they'll usually at the very top of the assignment, they'll give you like a list of functions and they'll have different like names for them, and then they'll just refer to those. Yeah. Okay. So this is what we have. All right, what is, now the one with the parentheses, I just put the parentheses there so I know where to plug something in. But if we had 1 plus 1, what do we get? 2. So I've got negative times the absolute value of 2. Now, what's the absolute value of a positive 2? It's just 2. So I got negative times the absolute value of positive 2, which is just negative 2. So there's my first number. Okay? And then over here, I've got the negative version of 1 to the third. What's 1 to the third? 1. What's the negative version of that? Negative 1. Okay. All right, so let's take our answers. Let's go back up here. Okay? So we're going to have 2 multiplied by the answer for m of 1. So what was the answer for m of 1? -2. Good. So 2 times the answer for m of 1 minus the answer we got for h of 1. So see how I just took my answers and I plugged them into this like little equation I got going on right here? See how I did that? So I got m of 1, I got h of 1, and then I just took those numbers I got and I like plugged them right back in. Okay? So 2 times -2 is -4. Minus minus makes a plus, +1, and so what is my final answer? -3. All right. How are the brains? Good? Brains are okay? All right. So I have assignments for you.